A bakery bakes cakes in small, medium, and large baking pans that are perfectly round in shape with uniform thickness. The medium pan is twice the diameter and twice the thickness of small, and the large pan is twice the diameter and twice the thickness of the medium. There is just enough batter to make 120 cakes in small pans. However, the bakery receives orders for only medium and large cakes. How many medium and large cakes can be baked from this amount of batter if at least one of each size must be baked? So this is an interesting and fun problem, and we'll start by considering the shape of a cake or a baking pan, right? So the cake will basically take the shape of a baking pan in which it is baked. And let's start with the small pan. So how is the small pan shaped? Well, it's perfectly round and it's of uniform thickness. So this is something, the small pan will look like. And it looks like a circle from the top. So if you do a cross section, it will be a circle, right? Because perfectly round. But it has some thickness, and the thickness is usually much smaller, probably, than the diameter. So the cake has an overall roundish appearance. But if you really think about, how the shape is from a three-dimensional standpoint, this will be more like a cylinder, right? And we can consider the radius as r, and then the height of the cylinder is basically the thickness of the cake or the pan, right? So let that be h, and then you have the volume of the small pan, and let that volume be v. So we can basically write v equal to pi r square h, and this is the standard formula for evaluating cylindrical volumes. So you have basically the cross-sectional area, which is the area of the circle, right? Pi r square multiplied by the height or the thickness. So once we do this, we can actually draw out the medium-sized pan, and this is not perfectly to scale, but the medium is basically twice the diameter, which means twice the radius essentially, right? And twice the thickness. So the height of this cylinder will be 2h and the radius will be 2r. And we can actually calculate the volume of the medium in the same way. It's a medium pan. That will be pi multiplied by 2r. The radius is 2r because it's twice the radius of the small. And its thickness is also twice the thickness of the small pan, so that's 2h. So it's pi multiplied by 2r whole square multiplied by 2h, and then if you do this simple calculation, you basically get 8 pi r square h. So that's the volume of the medium pan. And this is actually equal to 8 times V, where V is the volume of the small pan, and noting that V is equal to pi r square h. This is obvious, right? So the volume of the medium pan is basically 8 times the volume of the small pan. And let's draw out what the large-sized pan would look like. So it has twice the radius of the medium. So the medium has got a radius of 2r, then the large pan will have a radius of 2 times 2r, which is 4r. So 4 times r, and then twice the thickness of the medium. So the medium has a thickness of 2h. The large pan will have thickness of 2 multiplied by 2h, which makes 4 times h. So the question is, what's the volume of the large pan? Well, you can apply pretty much the same formula. So it's pi multiplied by its radius is 2 times the medium, and the medium has a radius of 2r. So the radius of the large pan will be 2 times 2r, and we'll basically square the whole of that. So it's 2 times 2r whole square. And similarly, the thickness is 2 times the thickness of the medium pan, and the medium pan had a thickness of 2h, so it will be 2 times 2h. So that will be the volume of the large pan. And again, it's simple to see that this is equal to 64 times pi r square h. And essentially, pi r square h is V, the volume of the small pan. So this is 64 times V, which is the volume of the small pan. So now we know what the volume of the medium pan and the large pans are in terms of the volume of the small pan V. Now it's given in the problem that there is enough batter to make 120 cakes in small pans. So if we are trying to estimate the amount of batter that's there, and I'm talking mainly about the volume of batter, right? So the volume of the batter will be basically 120 times V, right? So now we have to find out, with this amount of batter, how many medium and large cakes can be baked, right? So let's assume that with this amount of batter, we can bake, M medium cakes and L large cakes. So for each medium cake that's baked in the medium baking pan, right, we need 8V amount of batter, because the volume of the medium pan is 8V. And similarly, for each large cake that we bake, we need 64V amount of batter, right? So for M medium pans, we will need basically 8V multiplied by M, and for L large cakes, we'll basically need batter that's equal to L times 64V. So we have M times 8V plus L times 64V. So that's the total amount of batter you'll need for making M medium cakes and L large cakes. We don't know yet what M and L could be, but algebraically we can write this, right? So this is equal to 120V, because 120V was the total amount of batter. So we can write this equation, right? So if I'm making M medium cakes and L large sized cakes, and we need 8V amount of batter per medium cake. So for the medium cakes, we need M times 8V, and for large cakes, per cake, we need 64V amount of batter. So if you're making L number of large cakes, so the amount of batter we need is L times 64V. And we put them together, we add them together, we basically have the total amount of batter. But this should be equal to 120V, because 120V was the total batter, because, there's just enough batter to make 120 small cakes. So now if we divide both sides of this equation by 8V, we can do that because V is not equal to 0. It's the volume of the small pan, right? So we can divide both sides of the equation by any non-zero quantity. The equation will still be valid. And if we divide both sides of this equation by 8V, V basically gets cancelled out, and we are left with this. M plus 8L is equal to 15. And now the problem states that we have to make, at least one of each medium and large size. And we have something here that's M plus 8 times L is equal to 15. So if we substitute L is equal to 1, we're just trying to see if L must be at least 1, right? Because we need to make at least one of each size. So if L is equal to 1, then this equation still needs to be valid, right? M plus 8L still needs to be 15. So we just substitute L is equal to 1, and we get M plus 8 is equal to 15, which makes M equal to 7. So that's definitely one possibility. So we can make one large cake and 7 medium cakes with this amount of batter. But could we have any different answers? Well, the very next value for L, because L needs to be an integer, it's a number of cakes, right? So it can't be fraction, it's an integer. So the very next value of L would be L equal to 2, because that's the next integer, after 1. And if we have that value, we have basically m plus 16 is equal to 15. And because m plus 8L is always 15, so L equal to 2, so 8L becomes 16. So m plus 16 is equal to 15. And now m becomes -1. So we cannot have the number of cakes as 0 or a negative number, right? So this is inadmissible. And we don't need to test further values, because it's pretty easy to see from this that as we further increase L beyond 2, m gets still smaller, so m will still be negative, right? And that's something that we know is inadmissible. So the only possible answer here is 7 medium and 1 large cakes.